Okay, in this video I want to go over the atomic structure PowerPoint. Alright, the first thing is the atom. It's the smallest form of element that still retains that element's properties. Basic building blocks of matter are made up of protons, neutrons, and electrons. So it's composed of a nucleus in the middle. It's actually very small compared to the rest of the atom. Most of the atom is empty space. Now we learned from doing the atomic history that Rutherford discovered the nucleus, but he wasn't right about how the atom was set up. And then after he discovered that, Bohr came along with his model and said that electrons were in orbit around the nucleus. He wasn't exactly right. Somebody came up later on and built on his model, someone named Schrodinger, along with other scientists, and said that electrons actually were in orbitals around the nucleus in different energy levels. And that's the model we still use today. It's the quantum model, also called the wave mechanical model, and it's our modern model of how we understand atoms are. But you have this dense nucleus in the middle made of protons and neutrons, and the electrons are on the outside, moving very, very fast to where we can't even really pinpoint where they are at any point in time. We just have a kind of a probability of where they're at. Okay, so the nucleus again is it's positively charged because your protons are all positively charged, but your neutrons are neutral. So the nucleus in itself is positively charged. Neutrons act like glue that holds everything together. And your electrons are negatively charged. They occupy the electron cloud surrounding the nucleus. They're arranged into shells or orbitals, and they're not moving in perfect orbits, as we just mentioned. And the cloud can give us an approximate location where electrons are, but not a definite location. Like I said, they're moving very fast. And this is just an illustration of that. Okay, so subatomic particles. The proton is located in the nucleus, got a positive charge, and the mass of it is what we call an atomic mass unit. It's very, very small, very, very so small that really we just give them what we call 1 AMU to make it like a relative mass, how it compares to the other masses of the other subatomic particles. And if you notice, your protons are, we say, 1 AMU, neutrons are 1 AMU, so they're about the same size. And then if you notice, electrons are 0.00054 AMU, which means they are much smaller than the other particles, a lot smaller. And like I said, the electron cloud takes up about 99.99% of the volume of the atom, so the nucleus is very small. That's why in Rutherford's experiment, when he shot alpha particles at an atom, he expected them to go straight through, but every once in a while one would bounce back, and he knew there had to be something very dense that was in the middle of the atom, and that's when he theorized that the nucleus existed, and it had to be made up of positively charged particles. Now, one thing, the number of protons determine the identity of a substance. If you add a proton to an atom, it changes into a different element. And some properties of atoms we need to know is atomic number, mass number, average atomic mass. Now, your atomic number is going to be the number of protons. We usually show protons abbreviated as P with a little plus superscript there. And inside, if you look inside one of the boxes on the periodic table, you'll see two numbers. They're usually written one on top of the symbol and one on the bottom of the symbol. But you have 6 there is the atomic number. It tells you the number of protons. The mass number is equal to your protons plus your neutrons. We use neutrons with a little 0 as a superscript. And the average atomic mass is this 12.001. Is Saldes the one that's a decimal? And there's a reason for that. We'll talk about in just a minute. Alright, so on this periodic table, if you notice these numbers, like in chromium, we have the symbol, chromium. 24 is the atomic number, it tells us the number of protons. And a neutral atom, you have to have the same number of electrons. So it would have 24 protons, 24 electrons. And then this 52.00 is its average atomic mass. Okay, not one atom of chromium weighs that. But if you take all the different versions of chromium, something called isotopes, and took the average or the weighted average of those isotopes, it would give you 52.00. But if you notice, as you go from left to right, you add another proton. When you go to manganese, it changes into another element. Add another proton to manganese, you get iron. Another proton, you get cobalt. Okay, inside the square, like I said, you have the element name, the symbol, the atomic number. This is the whole number. And most times it's written above the symbol. Sometimes it's written below. The average atomic mass is written sometimes below and sometimes above, but just know it's the one with the decimal. Now, some of your, like sodium's abbreviation is, and its symbol is Na, because some of the elements, they go by the Latin name instead of the English name of the element. Okay, atomic number is the number of protons in the nucleus. I already said that. Each element has its own specific atomic number. And neutral atom, it's also the number of electrons. So neutral atom, protons, it's going to equal electrons. Okay, so the average atomic mass, before we get this number, it's an average mass of each of the different isotopes found for that element in nature. For example, chlorine has two different isotopes. Each one has 17 chlorine, 17 protons, and a different number of neutrons. That's what an isotope is. I mean, I said we'll talk about that later. That's not that important right now. It's to tell you that this 17 on both of these different versions of chlorine. If you take all the chlorine atoms, there are going to be some that have a mass number of 35, which means that they have that would be 18 neutrons. Because to get neutrons, you would subtract those two numbers, the mass number minus the atomic number, and this other one would have 17 protons, the same number of protons, but it would have 20 neutrons. So if you notice, an isotope is atoms of the same element with the same number of protons, but a different number of neutrons and different mass numbers also. But 75.77% of chlorine atoms are this chlorine 35. And then 24% of the chlorine atoms in the world are this chlorine 37. So taking the weighted average of those, it gives you the average atomic mass, which is the mass that's underneath the symbol on the periodic table. That's why you end up with a decimal there. And we rarely ever use those masses. We mostly use mass number when we're talking about different elements and atoms. Okay, so mass number is the mass of a specific isotope of an atom. It's the sum of protons and neutrons in the nucleus. So to find it, you could take, to find your mass number, of course you would add those. And then how do we find the number of neutrons? You take your mass number and subtract your atomic number or your number of protons, and you get your number of neutrons. Like I said, 35 37 are mass numbers, and you would just subtract the atomic numbers from them to figure out the number of neutrons. So how you gonna know what the mass number is? Well, I'll usually tell you there's one or two ways. And it says this first way: if you don't get the number given to you, to take your average atomic mass and then round it off. Sometimes we could do that, but most of the time I'm going to give you the mass number, or you're going to figure it out by adding your protons and neutrons, because it's less confusing that way. And there's a couple different ways. There's something called isotope notation. That's where you take the symbol, and then the left of it you put your mass number on top, your atomic number on bottom, and then if it has a charge, if it's something called an ion that we'll talk about towards the end of the week, then you put it to the right as a superscript. And anytime you see just a positive, that means positive 1. Like I said, we'll talk about that later on in the week. Now, to work some problems like this, because you'll be doing a worksheet like this, I'm going to do a few examples with you. First, if we look, we have the element boron 11. What is this boron 11? This is what's called, we call this, the element name. We want to put the mass number on the element name. It's also something called hyphen notation. So that's the mass number. So when I say it's boron 11, and I use my periodic table, my symbol I could put as B. I also could put B-11. So that's telling me that the mass number is 11. And then I look at the periodic table and the atomic number for boron, and it's the one that's not a decimal. That tells me the atomic number. It's also the number of protons. It's also the number of electrons. And then to find my neutrons, I take my mass number, subtract my protons from it. 11 minus 5 would be 6. Now next for carbon 12. For the symbol, again, I could put carbon is C, and I could put the mass number on that. And then I'll look at carbon on the periodic table, and you'll see that its atomic number is 6. So I would put that in there. It's got 6 protons. It also have 6 electrons. It's got 6 neutrons, and again the mass number, and like I wrote that down wrong, it's carbon 12, would be 12. Alright, next for magnesium, symbol is Mg. I'm talking about the magnesium's got a mass number of 23 instead of one of its isotopes that would have a different mass number. And its atomic number is 12. This also tells me it has 12 electrons. So its protons would be 12, because that's what the atomic number is. Neutrons is the mass number minus number of protons. So 23 minus 12 would be 11. Now, they're not always going to have, some elements will have the same number of neutrons as protons, but a lot of them don't. A lot of times they have more neutrons than protons, especially when we get into the heavier elements. Okay, if I look at this last one, if you're not given a name and you're trying to figure things out, and you don't know what has a mass number of 40, but you know that, well, if you can, the way you figure this out was if you have your mass number and your number of neutrons, remember protons plus neutrons equals your mass number. So if you subtract your neutrons from mass number, you get your number of protons. 40 minus 20 is 20. That also means it has an atomic number of 20. And if I'm going to name this, I'll look, so it has an atomic number of 20, and that would be calcium. Dash and whatever its mass number is, which would be 40, and then when I write the symbol, this would be Ca-40.